Welcome to Pulse Nucleum. Tonight we embark on a journey that spans the cosmos, delving into one of humanity's most profound and enduring questions. Are we truly alone in the vast, silent expanse of the universe? For centuries, this question has sparked our imaginations, fueled our myths, and driven our scientific endeavors. It is a query that touches the very core of our existence and our place within the grand cosmic tapestry. We gaze up at the stars, countless pinpricks of light, each a distant sun, many potentially harboring worlds of their own. The sheer scale of the universe suggests that life in some form might be abundant. Yet, despite our growing technological prowess, the silence persists. No definitive signal, no undeniable proof has yet reached us from beyond our terrestrial home. This paradox, the expectation of life versus the observed silence, is known as the Fermi paradox. It challenges our assumptions and compels us to look deeper, to listen more intently. Tonight, we will explore the scientific quest to answer this monumental question. We will examine the dedicated efforts of those who actively search for extraterrestrial intelligence. We will revisit a moment in history when the universe seemed to whisper back, a fleeting signal that left an indelible mark on the scientific community. It was a moment of profound wonder and lingering mystery. Finally, we will confront a mathematical framework designed to estimate the number of intelligent civilizations in our galaxy. This equation helps us organize our thoughts about the probabilities involved. Join us as we navigate the frontiers of astrobiology and radio astronomy. Prepare to ponder the possibilities, the probabilities, and the profound implications of discovering life beyond Earth. The search for cosmic companionship is not merely a scientific endeavor, it is a philosophical quest. It is a reflection of our innate human curiosity, our desire to understand our place in the universe. The answers, if they come, could redefine our understanding of life itself. They could reshape our philosophies, our religions, and our very perception of what it means to be intelligent. So, let us begin our exploration into the unknown. Let us consider the tools, the theories, and the tantalizing hints that guide our search for answers. The universe is vast, ancient, and full of secrets. Perhaps somewhere out there, another intelligence is asking the very same question. The formal search for extraterrestrial intelligence, known as SETI, began in earnest in the mid-20th century. It represents humanity's organized effort to detect signs of intelligent life beyond Earth. The fundamental premise of SETI is simple. If advanced civilizations exist, they might communicate across interstellar distances using radio waves. These waves travel at the speed of light, carrying information across the void. Early pioneers like Frank Drake initiated Project Ozma in 1960, pointing a radio telescope at nearby stars. This marked the dawn of a new era, moving the question of alien life from speculation to scientific inquiry. SETI is not about sending messages into space, but primarily about listening. It is a patient, persistent vigil, scanning the cosmic airwaves for any pattern that suggests an intelligent origin. Imagine the universe as a vast ocean, and we are listening for a distant ship's horn. We do not know where the ships are or even if they exist, but we listen nonetheless. The technology has evolved dramatically since those early days. Today, SETI projects utilize powerful radio telescopes and sophisticated signal processing techniques to sift through cosmic noise. These instruments are designed to detect faint, narrow-band signals that stand out from natural astrophysical phenomena. Such signals would be a clear indication of artificial transmission. One of the most compelling arguments for listening on specific frequencies is the concept of the cosmic water hole. This refers to the radio frequencies between 1420 and 1666 MHz. These frequencies correspond to the natural emissions of hydrogen and hydroxyl molecules, fundamental components of water. It is hypothesized that intelligent civilizations might use these frequencies for interstellar communication. The idea is that these frequencies would be universally recognized as significant. They represent a quiet channel, less cluttered by natural cosmic radio noise, making them ideal for broadcasting. For decades, the Arecibo Observatory in Puerto Rico was a cornerstone of SETI research. Its massive dish, spanning 1,000 feet, was an unparalleled ear to the sky. Arecibo's sensitivity allowed it to detect incredibly faint signals, making it a crucial instrument in the ongoing search. It scanned vast swaths of the sky, listening for any whisper of intelligence. Its iconic structure became synonymous with humanity's quest for cosmic companionship. It was a symbol of our ambition and our unwavering curiosity about the universe. However, in 2020, the Arecibo telescope suffered a catastrophic collapse. This event was a profound loss for astronomy and for the CD community worldwide. Despite this setback, the search continues. New instruments such as China's 500-meter aperture spherical telescope, or FAST, have taken up the mantle. FAST is now the world's largest single-dish radio telescope, offering even greater sensitivity than Arecibo. It represents the next generation of listening technology. The SETI Institute and other organizations continue to analyze data from various observatories. They employ citizen science projects, allowing millions to contribute computing power to the search. The search for a cosmic dial tone is a testament to our enduring hope. It is a recognition that the universe might hold wonders far beyond our current comprehension. Every day, these dedicated scientists and volunteers scan the heavens, patiently awaiting a signal. They are listening for a message that could change everything we know about ourselves and our place in the cosmos. The silence is profound, but the hope remains. The universe is vast and the possibilities are endless. On August 15, 1977, a moment of profound intrigue unfolded at the Big Ear Radio Telescope of Ohio State University. It was a moment that continues to captivate and mystify the scientific community. Volunteer astronomer Jerry Eman was reviewing printouts of data collected by the telescope. These printouts represented the intensity of radio signals detected across various frequencies. Suddenly, his eyes fell upon a sequence of characters that defied explanation. It was a string of 6 letters and numbers, SAT EQUJ5. This sequence indicated a signal that was extraordinarily strong, far exceeding the background noise of space. It was a burst of radio energy unlike anything previously recorded. Amon, astonished by the clarity and intensity of the signal, circled the characters on the printout. Beside it, he scrawled a single word: "Wow!" The WOW signal, as it instantly became known, was a narrow-band radio emission. Its frequency was precisely 1420 4x26 MHz, very close to the hydrogen line frequency. This frequency is considered a prime candidate for interstellar communication. Its proximity to the cosmic waterhole made the signal even more compelling. The signal lasted for 72 seconds, the exact duration that the Big Ear telescope could observe a point in the sky as the Earth rotated. This duration was consistent with a fixed extraterrestrial source. Its strength was remarkable, registering 30 times louder than the average background noise. This was not a faint whisper, it was a distinct, powerful burst. The direction from which the signal originated was also significant. It came from the constellation Sagittarius, a region rich with stars and potential planetary systems. Specifically, it appeared to emanate from the vicinity of the star group Chi Sagittarii. This area is densely populated with celestial objects, offering many potential sources. The characteristics of the WOW signal made it a prime candidate for an extraterrestrial transmission. It possessed all the hallmarks of an artificial, intelligent origin. However, despite numerous subsequent attempts, the signal has never been detected again. This non-repetition is the most frustrating and mysterious aspect of the event. Scientists have pointed telescopes back to the same region of the sky countless times. They have listened intently, hoping for a recurrence, but the silence has remained unbroken. Many theories have been proposed to explain the WOW signal. Some suggest it could have been a terrestrial interference, a signal from Earth bouncing off space debris. Others hypothesize it might have been a natural astrophysical phenomenon, though its narrow band nature makes this less likely. No known natural source produces such a signal. Another theory suggests it could have been a fleeting, one-time event from an advanced civilization. Perhaps a beacon that was only briefly active, or a message intended for another recipient. The lack of repetition means we cannot definitively confirm its origin. It remains an enigma, a tantalizing hint of something extraordinary that vanished as quickly as it appeared. The wow. Signal stands as a powerful reminder of the potential for discovery. It fuels the imagination and reinforces the importance of continued listening. It is a ghost in the machine, a cosmic whisper that continues to echo through the halls of scientific inquiry. It keeps the question of, are we alone, alive and urgent? In 1961, astronomer Frank Drake devised a remarkable formula. It was not intended to provide a definitive answer, but rather to stimulate scientific dialogue about the probability of extraterrestrial life. The Drake equation serves as a framework for thinking about the factors that might influence the number of intelligent civilizations in our galaxy. It breaks down a complex problem into manageable parts. It is a probabilistic argument, a way to organize our ignorance and identify the key variables we need to understand better. Each term in the equation represents a crucial step in the emergence of intelligent life. The equation is expressed as n x r x fp x any x fel psych x phi x fc x l. Let us explore what each of these mysterious symbols represents. N is the number of civilizations in our galaxy with which communication might be possible. This is the ultimate unknown we seek to estimate. R represents the average rate of star formation in our galaxy. We know stars are constantly being born, providing the raw material for planetary systems. FP is the fraction of those stars that have planets. Thanks to exoplanet discoveries, we now know this fraction is surprisingly high, with most stars hosting at least one planet. Ni is the average number of planets that can potentially support life per star that has planets. This considers factors like orbital stability and the presence of liquid water. Fel is the fraction of those habitable planets on which life actually arises. This is a profound unknown, touching upon the very origin of life itself. Phi is the fraction of planets with life on which intelligent life emerges. This considers the evolutionary path from simple organisms to complex, self-aware beings. FC is the fraction of those intelligent civilizations that develop technology capable of interstellar communication. This includes radio telescopes and other advanced signaling methods. Finally, L is the length of time for which such civilizations release detectable signals into space. This term is perhaps the most speculative, as it involves the longevity of technological societies. When we plug in our best current estimates for each variable, the results can vary wildly. Depending on the optimism or pessimism of our assumptions, N can range from 1 to millions. If we are optimistic about the prevalence of life and intelligence, the galaxy could be teeming with civilizations. If we are pessimistic, we might be alone. The Drake equation highlights our profound lack of knowledge about several key factors. The terms FL, FI, FC, and L are particularly difficult to estimate with any certainty. For instance, we do not know how easily life arises from non-living matter. We have only one example: life on Earth. We also do not know how often intelligence evolves from life, or how long technological civilizations typically survive. Our own civilization is still relatively young in cosmic terms. Despite its uncertainties, the Drake equation remains an invaluable tool. It forces us to consider the interconnectedness of astronomy, biology, and sociology in the search for life. It encourages us to refine our understanding of each variable through ongoing scientific research. Every exoplanet discovery, every breakthrough in astrobiology helps us narrow down the possibilities. The equation is a powerful reminder of the vastness of the unknown. It underscores the immense challenges and the incredible potential rewards of the search for extraterrestrial intelligence. Ultimately, the Drake equation is a testament to human curiosity. It is a mathematical expression of our deepest desire to understand our place in the universe and whether we share it with others. It compels us to continue listening, to continue exploring, and to continue asking the most fundamental questions about life beyond Earth. The answer to N remains one of the greatest mysteries of our time. If you like this video, share and subscribe. Pulse Nucleum.